Okay, this video is going to be about matrix multiplication, and it's not quite as straightforward as addition and subtraction. Matrix multiplication is a little bit different, and probably quite a bit different than anything you've seen mathematically. So let's go ahead and get into it. First of all, let's define what works. Here we have a 2 by 2, and we're trying to multiply it by another 2 by 2 matrix. Like I said in previous videos, always a good habit to write those dimensions, row, column, row, column. And the trick here is you look at the columns here and the rows of the second matrix. So the columns of the first, the rows of the second. If they are equal, then it's okay to multiply. We have a definition for multiplying as long as the columns here match up with the rows here. And that's interesting. What else is interesting is if you look at the outside numbers, the rows here and the columns here, that tells you how big your product's going to be. 2 by 2. Now, what I like to tell my students is if you think about what you're after. I'm after the element in the first row, first column. I'd like to know what that's going to be. I'm going to have 4 elements. I'm going to have one in the first row, first column, first row, second column. Okay? And what I'm saying is I'm literally telling myself which row in the first matrix and which column in the second matrix I need to multiply together to get that element. So for instance, this says first row, first column. So I look back here at the first row, which is my 3, 2, and my first column, which is my -1, -2. And that's the row and the column that I'm going to multiply to get this element. And you might be asking, well, I've got all these numbers, do I just multiply them all together? And that's not what you do. You start with the first 2, the first one in the row and the first one in the column, top one in the column, and you multiply them. So you get 3 times -1 is -3. Store that away in your brain. Then you take the 2 times -2 and you get -4. So now I've got -3 and -4. I combine those with addition and get -7. And I've got the first row, first column. Now I go to first row, second column. So that tells me to use the first row again, but this time with the second column. So this time I'll get 3 times 3 is 9, 2 times 5 is 10, 9 and 10 make 19. And so I've got the first row already done. Now I'm looking for the element in the second row, first column. So now I'm going to go second row, first column. I'm going to get -1 and +8. -1 and +8 actually make 7. Here I want the second row, second column. Second row, second column tells me to use second row and the second column. I'm going to have 3 and I'm going to have -20, and that gets me -17. Okay? So if you think about the element you're going for, I'm going for a particular element, and you think about its index into the product matrix, that index literally tells you which row in the first column and which column in the second. Now there's a nice pattern. You stick with the same row until you've gone through all the columns. You can think about distributing this row across all the columns and then going to the next row and distributing it across all the columns. It's another way students think of it. You can just practice with enough and you sort of get the pattern going in your head. It makes perfectly good sense. Take a look at this next one. Here they're not square matrices. In fact, they're not even the same dimension. And yet the columns here and the rows here match up. So this is okay. We can multiply these two. And when we're done, notice that the matrix is only going to be a 2 by 2. That's the outside numbers. Okay, so how does that work? How can we take these two matrices that are obviously larger than 2 by 2? Well, it's just the way it works out. I only have 2 rows to work with here, and I only have 2 columns. It's actually the same situation I have here. I have 2 rows and 2 columns. They're just a little bit longer. So again, I think I want the first row, first column element. So I look at the first row here and the first column here, and I end up with a 3 3 times 1 is 3, then 2 and 0. That gets me a 5. Stay on the same row, go to the next column. 4, 14, 4 and 14 make 18, and then a 0. Now I go to second row, first column. Second row, first column, I'll have a 9 and a 1 and a 0 for a 10. Second row, second column, this row and this column. I'm going to have a 12 and a 7 and an 8. 12, 7, and 8 gets me 27. Okay? And so that's how that can happen. Generally speaking, students struggle much less with the square matrices because they're obvious, they're going to be okay to multiply, and the answer is going to be the same size. Where they often get into trouble is when the matrices start taking on shapes that don't match, and the temptation is to look at it and say, well, we can't do it. When in fact, if you examine it properly, you'll notice that you can. And every test on matrix that included multiplication has always had a few problems like this that looked a bit strange, but could actually be multiplied. And then they'll usually have one like this. And if you actually do the analysis, you have a 2 by 2 here, a 3 by 2 here. And if you do the analysis of the columns here and the rows here, they do not match. So not okay. And again, just like when you are unable to do the addition and subtraction, the correct answer is undefined. And that's how you do matrix multiplication.